The APS 2300 Auxiliary Power Unit, APU, is a gas turbine engine designed to deliver electrical power and bleed air to the aircraft systems, on ground or in the air. The APU compartment is located in the aircraft tail cone and is accessible through two removable panels on the bottom side of the tail cone. The APU operates at a constant speed, rated at approximately 600 horsepower. It consists of a single-stage compressor impeller and a two-stage axial turbine mounted on a common rotor shaft. The gearbox assembly, driven by the engine rotor shaft, reduces the engine rotor speed sufficiently to drive the 40 kilovolt-amp oil-cooled AC generator and the oil pump assembly. The APU uses a full-authority digital electronic controller, FADEC, to operate various APU components. The FADEC also monitors the operation of the APU and provides fault and status information to the Aircraft Central Maintenance Computer, CMC. Additional maintenance information is available by downloading the FADEC data into a laptop computer. The APU compartment is located inside the aircraft tail cone. Removable panels located on the bottom of the tail cone allow access to the APU for servicing. Controls for operation of the APU are located in the cockpit overhead panel and include a rotary start switch and an emergency stop switch. The APU is controlled by the FADEC. The tail cone system provides a fully integrated fireproof tail cone. It is created from machined panels and stringers, fabricated from aluminum and steel. The tail cone is attached to the aircraft rear fuselage using 4 bolts and is a designated fire zone. A titanium firewall separates the forward end of the tail cone from the adjacent aircraft aft fuselage bay. The tail cone incorporates provisions for overboard drain, acoustic silencing of the APU inlet and exhaust, and 2 access panels for inspection, servicing, and maintenance of the APU system. The APU is attached to the aft fuselage by 7 struts. The steel struts are hard-mounted to the tail cone, with 3 struts going to the top of the APU and 2 each going to the sides. Each APU attachment point has an isolation mount made of an elastomeric material that is designed to isolate the APU from shock and vibration emanating from the aircraft. The APU air inlet duct is located in the aircraft tail cone at the 6 o'clock position and directs outside air to the APU compressor. The duct flange has a flexible seal which accommodates motion between the duct and access panel skin, and a mesh screen on the exterior surface to minimize ingestion of foreign object to avoid damage. The exhaust pipe carries the hot exhaust gases from the APU out of the airplane tail cone and forms the inner liner of the exhaust silencer, which consists of several baffles on the outer skin. This design provides acoustic noise reduction for the APU exhaust, and it creates cooling system eduction power by means of the controlled fit of the APU exhaust into this pipe. Fuel for the APU is provided from the aircraft fuel system right wing tank. However, it is possible to feed the APU with the left wing tank by using the cross-feed system. An APU feed shutoff valve, mounted aft of the fuel tank on the APU feed line, isolates the APU from the fuel system after APU normal shutdown or in an emergency shutdown. The APS 2300 APU is a continuous cycle engine that is made up of a centrifugal compressor impeller and two axial flow turbines that are connected by a common shaft. An electric starter is used to start the APU by rotating the compressor impeller and the turbines. The rotating impeller provides a high-velocity airflow to the diffuser, where the velocity is decreased and the pressure is increased. From the diffuser, the airflow is delivered to the combustion assembly, where the air is used for the aircraft pneumatic system and for the combustion process. The combustion process begins when the air and fuel mixture is ignited by the ignition system. The heated and expanded gases flow into the turbine section, where the high-velocity gases contact the turbine blades, which causes the turbine to rotate, driving the compressor and the gearbox. The gases leaving the turbine section flow into the APU exhaust system, where they are exhausted overboard. The APU engine consists of the reduction gearbox assembly, the air inlet housing assembly, the compressor section, the combustion assembly, and the turbine section. The gearbox assembly houses the reduction gears and is connected to the air inlet housing. Drive pads are provided for the generator and permanent magnet starter, located on the forward side of the gearbox. The lower part of the gearbox assembly is used as an oil sump for the lubrication system, from where the oil is drawn by a pump that is driven by the gearbox idler gear shaft drive. The air inlet housing is a one-piece casting that has a built-in perforated air inlet that directs air to the compressor impeller through the perforations. The perforated inlet also acts as a screen to prevent foreign object damage ingestion by the engine. The air inlet housing has external mounts for installation of the oil filter, the dual oil pressure sensor, the oil temperature sensor, the D' valve, and the speed sensor. The housing provides an internal support for the forward rotor bearing. The compressor section provides airflow to the combustion assembly for engine operation and bleed air for the aircraft pneumatic systems. The rotor assembly consists of a compressor impeller, driven by the turbines through a mid-shaft connection using a tie bolt and nut. The rotor is supported by two bearings, forward and aft. The forward bearing is a ball bearing which is mounted in a gauge that is secured to the inside of the air inlet housing. The aft bearing is a roller bearing and is located in the turbine section. The coupling ring, mounted at the front end of the rotor, is splined to the input pinion gear, which drives the gearbox assembly. The speed sensor uses the lobes on the outer part of the coupling ring to generate the engine speed signals for the FADEC. The combustor assembly is the hot section of the engine and has a combustion housing and combustion liner. The combustion housing forms an air plenum around the combustion liner and is connected to the compressor impeller shroud and the turbine section exhaust case. 12 fuel injectors, 2 fuel manifolds, and 2 igniters are located on the combustion housing. Bleed horns on the housing are used for installation of the bleed air duct and the anti-surge valve. A combustor drain restrictor is threaded into the bottom of the combustor housing to allow, when present, drainage from the housing. The combustion liner is a one-piece, reverse-flow annular design that is located inside the combustion housing. The fuel combustion process inside the liner takes place with air from the compressor mixing with fuel from the ejectors and igniting by means of the 2 igniters. The combustion process is continuous, and the expanding hot gases are directed to the turbine section. The turbine section uses the heated gases generated by the combustion assembly to drive the 2 axial flow turbines, which drives the compressor and the reduction gearbox. The turbine section main components are the exhaust case and the 2 axial flow turbines. The exhaust case is attached to the compressor section and the combustion assembly, and houses the turbines and the aft roller bearing. 2 thermocouples are installed in the exhaust, providing the FADEC with exhaust gas temperature information. Fuel for the APU is supplied by the aircraft fuel system, metered electronically by the fuel module, and then sent on to the fuel manifold. From there, it is directed into the fuel injectors, which spray the fuel into the combustion liner. The fuel module is mounted to the gearbox by a bracket. Components include the fuel filter and pressure sensor, the electric motor and gear pump, a fuel flow measuring venturi, fuel solenoid valve, and the fuel flow divider. The fuel filter is a disposable 10-micron filter element, replaceable by removing the threaded cap at the bottom of the module. In the event the filter becomes contaminated, a pressure sensor signals the FADEC to provide a maintenance warning when the fuel pressure across the filter reaches 8 psid. Note: the filter system does not have a filter bypass valve. The integral gear pump is driven by an electromotor that is controlled by the fuel module controller. The fuel module controller uses FADEC signals to adjust the electromotor speed to maintain the fuel flow demand for the engine. In the event of excess fuel pressure, the pump relief valve acts as a bypass valve by returning fuel to the inlet side of the gear pump. A fuel flow measuring venturi is located downstream of the gear pump inside the module. A pressure sensor measures venturi inlet and throat pressure and sends this signal to the fuel module controller. The fuel module controller adjusts the speed of the electromotor, thus providing an accurate fuel flow from startup until the ready-to-load status. The venturi bypass valve allows fuel flow around the venturi when APU loads require a higher fuel flow. When the APU start switch is selected to start, the fuel solenoid valve is energized open by the FADEC at 7% RPM engine speed, which then supplies fuel to the primary side of the 6 duplex fuel injectors. After APU light-up and an increase in RPM and fuel pressure, the flow divider opens at a fuel pressure of 150 psig, sending fuel to the 6 secondary duplex and the 6 simplex ejectors. When the FADEC de-energizes the fuel solenoid valve, the fuel supply is interrupted, which shuts down the APU. The ignition exciter mounted on the bottom of the gearbox, is a solid-state capacitor discharge unit that uses 28-volt DC to produce an intermittent high-voltage output to the igniters by two igniter cables. The exciter is controlled by the FADEC and is energized at 7% engine speed to supply high voltage to the igniters. The exciter continues to supply this output until de-energized at 55% engine speed. The two separate igniters are threaded into the combustor housing and extend into the combustion liner where they ignite the fuel-air mixture. Warning: the exciter provides dangerous high-voltage outputs. When replacing ignition components, be sure electrical power is removed from the exciter for a minimum of 5 minutes. The APU starting system consists of a permanent magnet and a brushless DC starter generator motor with its solid-state controller. The starter is integrated into the APU reduction drive and drives the high-speed shaft during APU start. It is capable of generating up to 1.5 kilovolt amp of electrical power during operation, which is used to power the fuel module motor and the starter controller cooling fan. The auxiliary power unit starting envelope is limited to 30,000 feet. APU starting may use either the onboard battery 2 or power from a DC external ground card. The APU operation is limited to 33,000 feet, and AC electrical power can be supplied up to this altitude. APU bleed air is provided for the engine starting system up to 21,000 feet, and for air conditioning purposes up to 15,000 feet. To start the APU, turn the APU master switch to the on position. This powers the APU FADEC and opens the APU fuel shutoff valve. When you momentarily turn the master switch to the start position, the APU FADEC commands the anti-surge valve and oil pump D' valve to open, decreasing the start load. The FADEC energizes the start controller, permitting to energize the brushless starter generator, BSG, and the APU to run. When the APU speed is approximately 7%, the FADEC commands the fuel valve to open and energize the exciter. At approximately 50% RPM, the ignition exciter and the starter are de-energized and the APU runs on its own. When the speed reaches 95% RPM, plus 3 seconds, the electrical and pneumatic powers become available. When the APU master switch is turned to the off position, the RTL, ready to load, pneumatic signal is immediately de-energized and the APU pneumatic power is unavailable. During cool-down period, electrical power and bleed are removed. After 2 minutes, the fuel valve, RTL electrical, and the anti-surge valve, if applicable, will be de-energized and the APU will turn off. When shutting the APU down, the D' valve again is energized to prevent oil pump output. The D' valve remains energized until FADEC electrically powers down. The FADEC power will be removed after 2.5 minutes. Note, the cool-down period does not apply during emergency shutdown. The APU supplies bleed air to the aircraft pneumatic system for use by the Environmental Control System, ECS, or for the main engine starting system, on ground or in flight. Bleed air is supplied through the bleed air valve, which is opened and closed by the FADEC using signals from the cockpit. The bleed air valve is located on the APU compartment firewall and connected to the APU by the bleed air duct. When operating in the ECS mode, the FADEC signals the bleed air valve to open and also directs the aircraft air management system to open the airflow control valves. If the APU exhaust gas temperature becomes excessive during ECS mode operation, the FADEC signals the AMS to modulate the airflow control valve towards closed, so that APU bleed air supply is reduced. During main engine start mode, the FADEC signals the AMS to close the ECS flow control valves and open the bleed air valve, directing bleed air to the starter valve. The anti-surge valve, mounted on the combustor housing, is electro-pneumatic in operation and is used to prevent compressor surge by discharging APU bleed air. Opening and closing of the valve is controlled by the FADEC using total air temperature, altitude, and airspeed signals that are sent from the aircraft air data computer. The APU control panel and switches are located on the cockpit overhead panel and provide control signals to the APU FADEC. The panel contains two switches, the master switch and the emergency stop switch. The master switch is a 3-position switch. The off position indicates normal shutdown of the APU after a 2-minute cooldown period. The 1 position indicates normal APU operation. The start position is a momentary position that initiates the APU start sequence, and when released, the switch moves to the on position. The emergency stop switch is a guarded switch which, when pressed, initiates an immediate stop command to shut down the APU. The starter controller system consists of a starter controller assembly and a permanent magnet starter, which is mounted on the forward side of the gearbox. The starter controller assembly, located in the APU compartment, consists of a cooling fan and electronic controllers for the cooling fan, permanent magnet starter, and the fuel module. The cooling fan uses ambient air from the oil cooler air inlet duct to cool the 3 controllers. The air is then discharged into the APU compartment. The starter controller uses DC electrical power from the starter contactor to supply power to the cooling fan and the fuel module controllers. It also converts DC power to a 3-phase AC power in order to operate the permanent magnet starter during APU start. The starter controller, in conjunction with the FADEC, controls the operation of the starter, shuts off the starter at 55% RPM, and is then converted into a 3-phase AC generator. The AC power output is then converted inside the starter controller to DC power to drive the cooling fan and fuel module controllers. The APU system incorporates indication and alarms for crew monitoring and maintenance indication for troubleshooting. The APU ICUS comprises 2 parts on the flight deck display: CAS messages alarms, fault and status, and APU speed and EGT indications. APU malfunction indications are recorded in the Aircraft Central Maintenance Computer, CMC. During APU operation, the following CAS messages could be driven by the FADEC for the APU system. APU fail caution. An APU automatic shutdown has occurred. APU fault caution. An APU major level fault is active. Shutdown inhibited because of in-flight operation. APU oil low pressure caution. The oil pressure is below the minimum limit. APU oil high temp caution. The oil temperature is above the maximum limit. An APU shutting down status, displayed in white, indicates that the APU is shutting down. Pneumatic loads are removed. Electrical power available. APU speed in units of percent rated speed and APU exhaust gas temperature, EGT, in units of degrees Celsius will be displayed in the flight deck display as a digital meter with 3 colors. Green for normal operational range, amber for precautionary range, and red for at or beyond safe operational limit. The APU incorporates a digital memory module which is located on the left side of the gearbox. The DMM electronically stores APU starts, APU operating hours, APU fault information, and APU and FADEC serial numbers. The FADEC updates the DMM with current information, which is stored in the FADEC non-volatile memory, and in the event the FADEC or DMM is replaced, data is automatically transferred to update the unit that has been replaced. Communication is possible between the DMM and a laptop computer. The APU oil system is a wet sump oil system which lubricates the APU gears and bearings. The main oil system components are the oil pump assembly installed in the gearbox, the D' valve, the air oil cooler, the oil filter assembly, the dual oil pressure sensor, the oil temperature sensor, the oil level sight glass, and the oil drain plug. The combination oil pressure and scavenge pump assembly is located inside the reduction gearbox and is driven by the idler gear drive shaft. The oil pump provides a constant oil flow to the gears and bearings. And scavenges the oil from the oil sump and the generator. The D' valve is solenoid operated and is mounted on the bottom side of the inlet housing. The valve is energized by the FADEC to prevent the oil pump from supplying the lubrication system during APU start and shutdown. The air oil cooler is mounted on top of the engine, providing cooling for the lubrication system. The cooler is fitted with a bypass valve that opens at 30 psid in the event that oil flowing through the cooler becomes restricted. The oil filter assembly, located at the bottom of the inlet housing, contains a disposable 15-micron filter element and can be replaced by removing the threaded filter cap. The dual pressure sensor monitors the oil filter for contamination by sensing the differential pressure across the filter. If the pressure reaches 35 psid, the sensor will signal to FADEC to provide an impending bypass maintenance warning. Incorporated into the filter is a bypass valve that will open if a filter differential pressure reaches 50 psid to maintain the oil supply to the lubrication system. The dual oil pressure sensor, mounted at the bottom of the inlet housing, incorporates 2 sensors which monitor low oil pressure and oil filter differential pressure, and then send their signals to the FADEC. In the event the oil pressure drops below 35 psig during normal APU operation, the sensors will signal the FADEC, which shuts down the APU automatically when the aircraft is on ground. The differential pressure sensor senses the differential pressure across the filter and sends a signal to the FADEC when a filter impending bypass condition occurs. The oil temperature sensor mounted on the bottom of the inlet housing monitors the oil temperature and sends a signal to the FADEC. Should the oil temperature reach 275 degrees Fahrenheit, 135 degrees Celsius, the APU will shut down automatically when the aircraft is on ground. The oil is serviced by opening the oil filler cap and refilling the oil sump to the proper level. An oil level sight glass, located on the left side of the gearbox housing, is marked with full and add, and provides visual indication of the oil sump level. The oil sump is full at 9 pints and low 7 pints at the add mark. An oil drain plug is provided at the bottom of the oil sump to drain the system. A check valve and a magnetic chip detector are incorporated into the drain plug. The check valve prevents oil drainage when the chip detector is removed for inspection. Oil system operation begins when the APU has been started and the engine RPM reaches 55%. Below 55% RPM, the D' valve is de-energized closed by the FADEC to provide rapid engine acceleration at startup. After 55% RPM is reached, the D' valve is energized open and oil is drawn by the oil pressure pump from the oil sump, where it is routed through the oil cooler. If, due to cold oil, there is excessive oil pressure, the cold start relief valve opens to protect the oil cooler, bypassing oil back to the inlet of the oil pump. Oil from the oil cooler then passes through the oil filter and through passages inside the gearbox housing, where it is supplied to the gearbox gears and bearings, to the generator, and to the forward and aft rotor bearings. A relief valve regulates the oil system pressure and is set to a maximum system pressure of 65 psig. During the lubrication process, oil flows through the system returns to the oil sump by gravity and 2 scavenge pumps. One pump scavenges the oil from the generator, and the other pump scavenges the aft rotor bearing. The reduction gearbox and the forward bearing are scavenged by gravity into the oil sump. During APU operation, an air-oil mist is created inside the gearbox and is separated by the rotating action of the air-oil separator. The air is removed through passages inside the air-oil separator into the gearbox vent line, which is connected to the APU exhaust. When shutdown of the APU is initiated, the D' valve is energized to prevent the oil pump from supplying the lubrication system. The oil remaining in the system returns to the oil sump by gravity and by the action of the 2 scavenge pumps. The D' valve remains energized until the FADEC is electrically de-energized 2.5 minutes after the APU master switch has been selected off.